am Annie. I work as a life cycle assessments expert at Miljögiraff. I do life cycle assessments on a daily basis in different projects, different products, and so on. I'm also helping Marcus out with CIMAPRO, as we are the agency in both Sweden and Finland, and also now some education. So for me, it's a great pleasure to be part of this education today, and yeah, get to learn some new stuff, and also to share with you what I know from this. And you, perhaps an introduction of you?
Yes, my name is Marcus Wending, and I've been running this CIMAPRO agency in Sweden since 2004. We support mostly companies in Sweden, but also universities with knowledge in LCA and how to use CIMAPRO. This picture that we are sharing now describes a little bit our ambition to be supporting the industrial partners very closely to find possible mitigations and very concretely doing changes in products. It's typically product management that we are part of. But we are also very interested in helping academia, and we also take part in some research projects. We have a network of 25 other CIMAPRO agencies around the world, and some of them are very academic and do a lot of research. Already in your presentations, I can hear that you are working on some issues that I know that some of our partners are also working on. So maybe we can link you together to help each other out more. From hearing your presentations, I can hear that you have very different experiences. Some of you have been working a lot with CIMAPRO, and some have not. And we hope to introduce you to CIMAPRO a bit here, while our ambition is to get into some details that we think are specifically interesting for you as researchers. But this is what you call it, a quick course, because there are so much possibilities. And we will send you a code after this one so that you can play around in CIMAPRO more yourself. And then we expect to have some more questions from you. All right.
Yes, let's dig into this. We thought we'd start off with a picture of the crew here at Miljögiraff. We have grown quite a bit, as you most likely are seeing as well. The demand for LCAs and that kind of work is rapidly increasing. So we've grown quite a lot just the recent year. So now we are at the moment 10 people at Miljögiraff. And this picture we took just this summer at lovely Vrångö. Yeah. So the agenda for today is that we have 2 sessions. The first session now before lunch, we will have from 10 to 12 of 2 hours with a break in between, in the middle, a few minutes so that we can catch our breaths. But we'll go through a little bit of introduction to environmental LCA from our point of view, and we'll also go through a little bit about endpoint indicators and midpoint indicators. And we'll also dig into creating impact methods a bit and show you where you can find methods in CIMAPRO and where you can play around with this yourselves. And after lunch, we'll go into session 2, which is the next 2 hours, where we go into a little bit more how to easily change background databases and focus on uncertainty and sensitivity analysis and also scenarios. This is about how we thought we'd schedule the day. It might change a bit due to how much time different parts takes. And we are open for you to ask questions at any moment during this. Please interrupt, please raise questions, and so on. We prepared some subjects as far as we could. But if you would like to dig deeper into something or have any questions regarding anything else, don't hesitate to interrupt us. Yeah, so let's start. When we think about LCA, we work from the LCA perspective. So you can have different perspective. We look at products from a life cycle perspective, but you can also put them into other systemic perspectives, social perspective. As you said, you now have the course within social LCA, which is another perspective. But we work with LCA often from a product, very product specific view. And we try to use the method of life cycle assessment to find strategies that are sustainable, that we try to steer sort of in the right direction by finding what is big and what is small from the life cycle perspective, so that we dig deep and we see what lays behind the surface, and then we target the hotspots that really matters, that gives as much benefit as possible from these specific actions. Anything you want to add?
No, I think it's important to remember that we are dealing with the assessment of impacts rather than analysis. And sometimes when LCA as a method is used, it's interpreted as something that is very scientific and fact-based and detailed. And it's we from our perspective, we use it in a little bit broader sense and try to stress that this is something we use to point out the direction rather than understanding everything about everything.
Yeah, it's one dimension, some different aspects. Yes. So we thought we'd start to share some examples from our work to sort of show you how you can use LCA and what you can conclude from different projects. So one example that we have is when it comes to coffee, and you have this packaging in metal containers, and then Marcus did a life cycle assessment of this a few years ago, where they saw that portion cups of coffee is actually a better choice than larger packages, because this shows that disposable packaging is not always a bad option, because in this case it could reduce the amount of beans that had to be produced because you had exact portioning of the coffee. And that was the most important factor in this particular life cycle assessment. So that was a conclusion that maybe was surprising at first when you had your initial idea of where the results were to go. So since the capsules were in aluminium, they could be recycled and so on, and that really affected the results. And that's one way to utilize LCA.
Yeah. Quite often, I think we have a lot of environmental myths in society about things, and LCA can be used as a myth buster to have a more better understanding of the whole system.
Yes, sorry, may I ask?
Yeah.
I don't understand. What really did you compare? The impact of the packaging with here, I see the same packaging, or?
You compared the entire value chain, right? The coffee and the packaging in itself.
Yes, we made the comparison with brewing coffee in a can, and also with Nescafe.
The instant coffee.
Instant coffee, yes. So that was the perspective. And this was, I should say that as well, this was something we did internally. So it was not intended for external communication, but it ended up as something that we couldn't protect the information. So a lot of people were super interested in this, and it became a viral discussion on Facebook. So it was quite interesting. Yeah.
Yeah. Good question. Yeah, and then we have another example of where we try to assess the impact from different hangars. So there was, I apologize for this being Swedish on the right hand side here, but the bar to the left, the dark green one, is for a paper hanger, which was the initial case, and then they compare that to the bar to the right, far to the right of the polystyrene hanger. And it turned out that the paper hanger was better. But then in communication with these clothes stores, they realized that there is a more common case where you use a plastic hanger and then you recycle it multiple times. So then you had to change the perspective of the LCA and try to assess a hanger that is recycled to these other options. And then it turns out that the plastic hanger that could be reused again and again as a measure of a circular action was actually a better option over time.
Yeah.
Yeah, that is another example. We have several examples we can give some of them as well, but we thought that it's a nice way to get into this, sort of to get your brain working. I'm sure that you have many examples among yourselves as well.
Yeah, and this example is another one where we explain and elaborate around the lifetime of a product. So in this case, it's an elevator, and for elevators, it's really important to consider the lifetime of the building in which the elevator is installed. Typically in Sweden and everywhere in Europe, elevators are exchanged every 20 years because that's a norm regarding the safety standards, and it has to do with a wire elevator that is, hanging from the top of the elevator, and in order to be secure, they have to be reinstalled every 20 years. But we were looking at another type of elevator that doesn't have this hanging structure. Sorry. And in this case, it's possible because they don't have the same security regulations. So it's possible to actually exchange parts over the lifetime in a better way. So in this diagram, we are comparing this kind of elevator, which is called hydraulic, with an ordinary wire-based elevator, which is called a traction elevator. And then we can see that in the perspective of the building lifetime, such as 80 years, it is a much lower environmental impact with a hydraulic elevator. And and this case shows that it's important not to be blind to the norm of what should be compared, in this case energy, because materials was actually more important than the energy for a moving elevator. And a key to the solutions was modularity, so that you can exchange parts in a smooth way and have a scheme for that during the lifetime. And also the functional unit is very important here. When looking at an elevator during the whole lifetime, we can see, like the diagram shows here, that it's better with a hydraulic elevator. But if we use the functional unit that is actually chosen for the environmental product declaration, then the functional unit is per person transported 1 kilometer. If we use that functional unit, we will have another result, because a typical hydraulic elevator is not used as many kilometers as an ordinary traction elevator. So that was a lot of learnings in this project.
I think we can skip this one because we'll go into the same kind of same kind of example here, how you can use CIMA-Pro and the results from CIMA-Pro then to derive hotspots and find the source, what we were talking about before, what is big and what is small from a life cycle assessment. And in this particular assessment, it was this kind of screen provided by Lintex. And after building the model and extracting the results, it could be seen that most impact, and in this case, it's climate change potential, was generated from the wool fabric used in this screen. And then by using life cycle assessment as a tool, you can then build strategies for improvement. So the change was then to we built a scenario, we tried out polyester instead, and it led to a 30% reduction. So now this company Lintex are working on purchasing recycled polyester instead. And they have then identified that they could save a lot of climate change potential over the year just on this version of this screen. So this is a way to use life cycle assessment in order to create benefits. Yes, Dalia, I see that you're raising your hand.
Yes, I have a question about the elevator example. You mentioned you used two functional units, one that you assumed, and then when you did the EPD, you had another functional unit. So why is that? Is there like a standard for the EPD or some kind of special functional units for the EPD?
Yes.
Yeah, exactly. When you do environmental product declarations, you have to follow specific product category rules. And in this case, that has been determined by the elevator branch as a whole in Europe. And that organization came up with a PCR that has the functional unit, 1 person, 1 kilometer. And we have, it's interesting that you asked, because we were very much involved in trying to change that functional unit in this PCR. But we didn't come all the way, but we managed to change something that in these EPDs, you are obliged now to say in which category your elevator is working. So there is a category for elevators that are making only a few travels every year, and for those that makes a lot of travels every day. So we are partly happy about that.
Thank you for the clarification.
Yeah, I think this one is done.
Yep. We also have another case here with for how to derive the results. And this is about a lamp or lamping structure. We did quite often we use a single score where we group all the environmental effects together to understand what is the overall most important factor. And in this case, we can see how it's distributed over the life cycle phases. And for a lamp, it's not surprising maybe that the usage with consumption of electricity is the most important. But that is also a bit strange in the comparison with a functional unit, because actually the lifetime will be longer if you have a better lamp. So it means that you will consume more electricity over time. So it's actually more interesting to focus on the raw materials from the producer's perspective, because they have already decreased the amount of energy required in the lifetime as much as possible. And then you can see from the different colors in column A that it's easily to trace what environmental impact effect category is the most critical one. And then you can dig further into that result to understand if it's relevant and what you can do about it. maybe that's. And yeah, I must say also that when working with this specific client and this specific product, we found savings that could save 450 tons of CO2 every year from only this product. So that was quite fantastic, I think.
I've got a question. How are these weighted points calculated? I mean, you are sort of trying to have to aggregate everything, so you need to have a common like unit, right? How do you then say maybe climate change is for raw materials is maybe somewhere around 2 points, and then resource use is maybe 15 points or something like that? How do you come to that?
Yes, we are going to dig deeper into that in this afternoon session, I think,
Yeah, or just before lunch.
Or before lunch. But there is actually a weighting method, which is a bit more subjective. And for that, we use common units. So we have to relate these different effects to the same units. And those units are related to safeguarding objects, such as human health or resource consumption or depletion, or environmental degradation in terms of ecology. So we need a safeguarding object to compare it in relation to, and that makes it very subjective. So therefore, this type of information is mostly for internal elaborations and understanding what is most important.
Yeah, and to decide how to do those factors, we use the already implemented methods that are common in the LCA world. For example, the environmental footprint method, or recipe, or any of those that already build on scientifically decided ways and how to do this. There are ways that they have decided this should be weighted in this particular way, and that's why we try to stick to them as far as we can when doing this. But as you say, these kind of results are usually used internally in a way to highlight what is most important to focus on, rather than for external communication. But we'll dig a bit deeper into that just before lunch. So please come back to us if we have not answered the question by then.
Okay, this is a final example, I think, which was interesting because it was an LCA made in a prospective way. So we had a company that produces air filters, and they were looking for possibilities to reduce the environmental impact in order to differentiate themselves on the market. And so we tried out the LCA with many different materials and changing the functional unit and things like that. And we actually arrived at a solution that in this case means that because the filters have to, by regulation, be sent to incineration, it was better in this case to change from plastic to metals, because metals can be recycled even though they have been sent to incineration.
In the frame itself, that's where they change the materials so that the filters are incinerated, but the frames can be recycled as they are made from steel instead.
Exactly. And in this way, this particular solution could differentiate itself a lot on the market and make a huge difference. We calculated the importance of this for the municipality in Uppsala, actually. I think a lot of you are positioned in Uppsala. And it was very surprising results, because there's a lot of filters being used and a lot of incinerated materials. So we could reduce the environmental load by, I think it was in the order of 14 ton CO2 every year. So it's rather important.
Yeah, and made quite an important impact on the business itself of air filters.
Of course.
As the rest of the business also decided to change. Most of them decided to change the way they design their filters as well. So that is very interesting, and that is a great example of how you can use LCA to find these hotspots.
Yeah. And actually, this example is also, there's a picture of a film, a video we made of these results. And I think that is important to remember, that it's possible to improve the communication of the results so that we can reach an audience. Back in the days, I'd say, but maybe just 5 years back, we were always making these environmental reports, which we still do, but not so many people are reading them. So we are trying to convert the results into videos that is possible to communicate to a broader audience.
Yeah, I'd say that the audience might have changed.
Oh, definitely.
That is probably the most important change, that the people that read the LCA before, they knew what they were reading, and now the audience is perhaps not at that knowledge level. So you have to adapt your communication of the results accordingly to how they will perceive the results, to make it easy to understand. Let's move forward. So by these examples, we have already sort of introduced how you can use LCA, so that you can provide it as a basis for design, how you can redesign the products, as with the air filters, for example, use it in product and product design. But you can also use it for management in a company and in management systems, or how you choose to design your business model and so on. I'm sure that you have encountered several interesting projects that all dig into these three topics that we present here. But the final one is also that you use it for communication, and we touched upon that subject with videos, but you can also create environmental product declarations and use them for communication. And as we see in Sweden, the building sector is especially pushing for EPDs nowadays. So that is a demand that really has increased a lot. But mainly, yeah, these are three ways that you can use the life cycle assessment method in order to help out.
Yeah.
Going into Sima Pro, we will show a few pictures as well. We might jump back and forth in some topics as well today. Please let us know if you want us to dig deeper in something, we should show something more. But if we start with how you can use Sima Pro and the expected results that you want to extract from this tool, you want to be able to present, in according with the ISO standard, of course, what are the relevant environmental effect categories, and that you can single out by using, as we mentioned, the weighting methods to see which impact categories come through as more important than others, maybe, or where should we put more focus. But then we can also dig into the impact per phase of life cycle, as we showed with the example with the lamp. Where do we have most impact? And you can do this on several different levels in one particular impact category, on midpoint level, or on an endpoint level, or also on a weighted basis. And then we can go from there also through the impact per phase of life cycle, but also down to the most important aspect. If it's a particular raw material that is the most contributing factor to the result. So this is what we expect to be able to extract from Sima Pro, and what we can extract from Sima Pro in different ways. Yeah. And in Sima Pro, we work partly with these Sankey diagrams that we can see here, as I'm sure many of you are familiar with. where we start on a level where we have the life cycle of the bike on top. Here is an example with the bike. And then we can break it down into life cycle phases. And depending on how we group the results, we'll see that which life cycle phase is most important. And we follow this by looking at the thickness of the arrow. So the thicker the arrow, the more impact. And once we come to the conclusion which life cycle phase is more important, then we can dig down into components if we model it by component. Then we'll see here in this picture, for example, that the frame is the component that contributes with most impact. And going further down, we can see which raw material here is the hotspot, in this case, aluminium.
Mhm.
And what we can do in Sima Pro as well is to open a tab where we mark, for example, on the life cycle phase level, we mark the bike and we'll get this little screen that is shown to the left here, where we see the name, which is a bike, and then we'll see which inflow contributes most in actual numbers here. This is from another example, so it might not match completely with the numbers displayed in the Sankey diagram, I just realized, but these are different kind of ways to navigate in Sima Pro and to see, to derive results and find the hotspots.
Maybe it's also worth mentioning that in every node here in the network, we have information. So the information in the top of the node is how many or how much of that that inventory data is used. For example, here it's one piece of a frame. And then to the left in the lower corner, we have the result of that specific impact assessment method that is used. So in this case, it's maybe 4.01 kilograms of CO2.
I see that we are missing the units.
Yes,
Sure.
the units.
Usually the units are displayed, so we'll see them when we go into Sima.
And you have also the what you call it, the meter, so that you can have a visual feeling of the importance of each node in comparison to the overall picture.
Yeah.
Mm-hmm.
And this is the type of results that you can find in Sima Pro then. And as we said before, you will have a code that you will be able to navigate in Sima Pro and look into this as well.
Exactly. Maybe worth mentioning also the table that Annie mentioned. Normally we have this distribution here between the different inputs to one node. But at the top, you can also see that there's a row that says contribution, and it refers to how much this specific node has an environmental impact without the other inputs to it. So say, for example, if we have a combustion of wood, then it would be a very large portion contributing to CO2 from the specific node itself. So now it says 0%, but if we have combustion of wood, it would be maybe 60%.
So that would be sort of the environment, the elementary flows
Exactly.
in a process or in a node. So in the inflows, you will see all processes or assemblies that are inflows, but everything else that is a specific emission or another type of elementary flow will be shown to under the contribution tab or line. Sure.
Okay. Okay. So now taking a step to the next session here, just for the terminology that is used when we do impact assessment, we talk about an environmental aspect such as driving a car or emissions from driving a car can have an environmental effect such as a greenhouse gas effect, and that we call a midpoint in the calculation methods. And that will contribute to a potential environmental impact, which is a damage on a safeguarding object, such as health and ecosystems. And in those calculation methods, we call that an endpoint. So something that we do contribute to an effect that damages something. And this is the framework that we have been working on since the beginning of LCA, life cycle thinking, from maybe the 60s. It goes way back, even if it was becoming more popular in the 90s. But I think it tells us something that this concept has to be further developed all the time. And we are still relying on a concept that was developed a long time ago. So, for example, those damage, how we measure the damage relate to safeguarding objects that we maybe need to, of course, I mean, we have to develop further. So, for example, in this presentation from Laura, she was talking about the social perspective, and that is something that is not covered very well by the conventional methods.
Yeah. And as you mentioned previously, going from the aspect, the actual emission of, in this case, CO2, to the midpoint effect, that of course has to include some sort of factors that convert this, that weigh this. And there are methods for that established, as you say, that are already in use. And then when going from midpoint to endpoint, we have to do another weighting or another type of set of factors that we use to come from midpoint to endpoint. And there, due to the difficulty in assessing damage of health and ecosystems, that also introduce a larger set of uncertainty the further you go towards endpoint. It can be worth mentioning.
Yeah, this definitely, thank you. This can be elaborated further so much, and if you have some specific questions, just please enter into the discussion. Otherwise, I continue a bit further.
Dalia, you have a...
Yeah,
I see.
okay.
Yes. Yeah, I have a question, but it's, well, thank you for this very interesting presentation. And I'm just thinking about the communication part where you mentioned that you were using videos for communication. And it's, for me as a researcher, it's very challenging to communicate my research to the different stakeholders. So is it possible to share with us one of these videos or to give us a more deep idea? How do you do it?
Yes. We will send you some links afterwards.
Thank you.
Normally, we put the videos on YouTube, so that's easy for us. David?
That's great.
Hi, I just wanted to ask, will we have a short break at the hour point?
Yeah, we will.
Okay, good.
Super.
Already getting tired of us. What's this? Just kidding.
I just don't want to miss it.
Yeah, I completely agree. We should have a short break when we reach 10 o'clock.
So, Laville?
Sure. When different ways of using these midpoints and endpoints results is that when you use your environmental impact assessment, you can present the results at a midpoint level, which commonly could be as shown to the left, or different impact categories, and yeah, they could be decided by, for example, PCRs when developing EPDs and so on, or already pre-decided in the methods that you use. And so you have to adapt this depending on the purpose of your LCA, of course, and what you want to look into, and and then use the method that you want to, that properly represents the type of results you want to display. But when we go from midpoint to endpoint, we can also choose to choose which endpoints we want to display as well. And what we usually look at is that some endpoints can be sort of connected to the planetary boundaries. It is not a one-on-one connection between the endpoint categories and the planetary boundaries, but we've tried to dig into it a bit deeper, and we can see that there is a higher correspondence between some of the categories, for example, climate change, and a lower correspondence for others, such as the resource use is quite low correspondence. But a way to use these endpoints from our perspective have been to sort of try to look at the planetary boundaries as well, like how can we use them to connect and talk about it in a way that we also connect to the planetary boundaries.
Yeah, and related to that, I would like to add that there has been a group working on how to make this relation work. A group of life cycle experts in a project called Absolute LCA. So they're trying to relate to the carrying capacity of the overall system, and also relating to what specific sectors are contributing most to parts of these impact categories. For example, the automobile sector is contributing to climate change, and how much is it doing so? So then it's interesting if you can say that one automobile manufacturer has a better solution for reducing the climate impact in relation to the rest in the group. And this is a very complicated, of course, complex, but it's absolutely possible to do. And we can see some of those results coming into the roadmaps of different sectors. So the World Business Council of Sustainable Development, they have initiated some of those roadmaps, which I think is very interesting.
Mm-hmm. Yes, let's move on. Yeah, so this is a way for us to try to illustrate the different levels of midpoint and endpoints, how you can present the detail both aggregated and in details. If we start at the top, we have the single score, as we talked about before, the weighted results, the endpoint. And that, of course, relates to the damage on health and resources and ecosystems. That is the basis for this single score, the endpoint. And below that, we have the categories of impact, the midpoint level, which we then can break down into impact per life cycle phase, and then the specific contribution from different processes present in our life cycle. And from that also down to specific environmental aspects. And it sort of connects to the topics that we talked about before. But this is a way of trying to illustrate that from bottom to top. And we have extracted on the next page some midpoint level results and examples of how you could illustrate them. If you have a textile sheet that you can make in different materials, then you can distinguish which midpoint level. Oh, now it's going crazy. Which midpoint level results that are particularly interesting, and then you can choose to extract those specific categories and present them more in detail. So here, for example, we have water depletion, agricultural, land occupation, and fossil energy for these three different types of materials. And we can see how it varies between the different materials in each of these categories.
Mm-hmm. And this is one of the mostly used methods that is included in CIMA Pro. It's called Recipe, and it was developed by a group of universities. Many of them, or a few of them in the Netherlands, typical European focused, but also contributions from the US and Asia. I say that because I think it's important with a cultural understanding and the different experience that you have from what is important environmental impact. So starting from the left here, we have some environmental aspects that we have data for in our life cycle model. It could be, for example, an emission of CO2, or how much land use that we need for this production, or consumption of raw materials and things like that. And each of those can have contribution to different midpoints. So the most easy one is that CO2 contributes to climate change, and how much does it do so? So that mathematical relationship has to be established, and it's described in physical units in terms of kilograms or square meters and things like that. And from then on, the effect that climate, how that substance is actually having an effect on climate change, or on how that relationship is described, is also a mechanism. In this case, it's called infrared forcing, which we know as greenhouse gas effect. And that relationship is also physically determined, so we can actually agree almost perfectly in science on how much a certain substance is contributing to infrared forcing. So that part of the equation is called midpoint, and is very objective, I would say. And then the next step is to say how much this is contributing to damage on certain safeguarding objects. And that is more subjective, because it depends on what we compare it with. And that process is called normalization. So we have to normalize the importance of these impacts, or this contribution, in relation to how big this issue is in a certain geographic area or so. So normalization is a very important phase in this, and it depends on your perspective. Of course, if you have a European perspective or a global perspective, and also if you have a societal perspective or an individualistic perspective. So yeah, there's a large complexity in that, but we are trying to make it as simple as possible for the end user by just talking about the safeguarding objects. And those damages can be related to the safeguarding objects, which, for example, everything that is contributing to human health is expressed in the unit daily, which is years, how much a life would be reduced with this damage. Yeah, I see that Stanley want to contribute.
Oh, it's actually a question. So I've seen some articles where they say maybe for pork, the important impact categories are climate change, land use, and eutrophication, and so forth. So my question is, how do they come to that? I mean, to say that these are important, is it because of the contribution to the end point, or what? Because they'll be talking about the midpoint, so I sort of get lost. I mean,
yeah. That's very confusing, actually. Normally, when in this method, for example, recipe, we relate it to endpoints that are agreed upon in a panel. So experts have come together and agree on the different importance of those safeguarding objects. And by using that, we can say which midpoint is the most important. But there are other schemes that are looking at the political targets that we have in a country or so. And then we relate to how far we have come on that issue, that environmental problem. So that can also be completely relevant. And there are other methods which are relating to our willingness to pay in society for avoiding certain damages. And that is a little bit more objective, I would say, because it reflects the price of making a change and also the possibility of having a budget for changing something. So all those perspectives are important to consider when claiming that one midpoint is more important than another. And I think that is a problem because we want to simplify things as much as possible, but everything is changing. So we should, it would be better if all these weighting schemes was being updated continuously. But that is not really the case. So we should handle such statements with a large proportion of caution.
Yeah, and then you can weigh those in this image, those safeguarding objects to a single score as well, through different factors. So related to your question there, Stanley, I would guess that they would use the endpoint to try to derive which midpoint categories are most important in those articles. But as you say, it might be hard to derive how they come to that conclusion.
Thank you. David, I see you have a hand raised.
Yeah, kind of a question connected to Stanley's question. And that's, it's kind of more academic, I suppose, but I understand that the LCA process and maybe this recipe method, it's kind of a standardized method. And I've noticed in scientific publications that when reporting these impacts from a study, they often list all the impacts, and the reader, I think, often wonders, well, why, what is the real importance of some of those impacts? For example, if you list some marine damage, but you're studying a terrestrial system, for example. And one question I had is that part of the standard that you have to report all those impacts, or is the researcher free to pick and cherry pick the ones? What is kind of the standard approach in
Yeah, I can try to answer that. If you're communicating externally to a market, you have to follow the ISO 14020, which basically tells you that you should communicate in a way that is relevant for your respondents, the receivers of your communication. And when it comes to automobile product declarations, for example, then some of those impact categories are chosen and said that you have to communicate these and you should not communicate others. So then it's easy. But if you are a researcher and present your results of a life cycle assessment in a more academic perspective, or in a broader context than reaching to a market, then it's actually up to your knowledge to choose which one to present. And I would say that is much more difficult because you have to be aware of the rest of the knowledge in this academic group.
Yeah.
So, yeah, I see that Priscilla is.
Yeah, I think I can contribute a little bit on there because I have published LCA studies, and what we usually do is that, I mean, you know your system and you should know what are the most important categories, not saying that they're not all important, but a good way to select it would be to, when you have the normalization, you see whichever pops out more, so they have higher impacts. But also looking into the literature and seeing what others that have looked into similar studies have used as impact categories and why they say it's important or not. So in my papers, I select a few and I justify why am I choosing these ones. So for this sort of system, these 5 are the common ones, but I'm also adding this and this because of that. So you usually go by what people have been doing, and also to make it comparable. So if you're gonna want to compare your result with someone else's, so then you need to have the same impact category assessed.
Exactly. Very well. Actually, oh, sorry. If I go back to this picture, we can see that if we would do a life cycle assessment on only one of those materials, maybe we, for example, with polyester, we would leave out the information about the water depletion and the agricultural land occupation. But then, as Priscilla says, then we couldn't compare it with the other relevant materials in this case. So therefore, it's really important to understand the context in which we are presenting the results.
Yeah, I think it might be time for a break. I think we have one last picture on this topic of the results, but then we can go for a few minutes of break. This is just an illustration of this kind of endpoint results where you have included all of the impact categories, and you can also derive which ones are most important from this perspective. We can see in this diagram that the materials and assembly is by far the most important phase, as we see, and this is the weighted results, all of them on top of each other, but then we can also see which category stands out, as Priscilla mentioned. You can also use normalization results to try to identify the biggest ones, like use a method where you can try to identify which ones are more important, also look at maybe what others use, but then you can extract these type of diagrams to also illustrate which ones are more important and which are not.
Nice. And yeah, then maybe we should, as Annie says, go to have a break.
Yes. And then we'll go into the methods after the break. So we'll be back. So as we spoke about previously, there are many different methods that you can use for your impact assessment. And of course, you have to adapt it in regards to the results that you want to present. But in CIMA-Pro, there are several of these predefined methods available. And here is a very long list of those you can find, but we thought that we could also go into CIMA-Pro now to show you in the software where to find it. So if you open CIMA-Pro, just to show you later on for when you are going to scroll around yourselves, try to find out the different options. Vi testar. Om du öppnar mätställmakaren igen så trycker bara ner in i hela den. Ibland ställer du måste ta upp en där nere. På ändra.
Ja.
Du måste trycka på ändra-ikonen liksom.
Ja, just det.
So, good. We just close this window for now. Or minimize it.
So, okay, skip that one.
Go to the
here. So when you, I just jumped into CIMA-Pro, and in CIMA-Pro, I don't know, maybe not so many of you have been working inside CIMA-Pro. So I just introduce it briefly, and in the menu to the left, we have the ISO standard structure. And in the top menu, we have all the functionality in CIMA-Pro, the different functions you want to do. such as getting back, finding data, open specific sheets, and far to the right here we have different calculation setups, analyze, compare, and uncertainty analysis. Now what Annie were talking about before, the methods, we find them here under impact assessment.
So we can see that the bar to the left here, we have the wizards on top, and then we try to follow, or the software itself is building according to the 4 phases of the LCA methodology defined in the standard. So we have goal and scope, inventory, impact assessment, and interpretation to the left. And if we go to methods below the impact assessment, we end up here.
Yeah, and for some reason we cannot see the whole scope now. So there you go.
There we go. Just have to add some bars here.
It goes.
Good. So when you want to find a specific methods in CIMA-Pro, you go below the impact assessment header to the left, and you find the methods bar, and then you end up here. So you can, and here we have a bunch of different methods to choose from. And if you open one of them, for example, the environmental footprint method here, you can double click on this one to open it. And we pray that our remote desktop is with us today. Usually when you have this video meeting, it takes a bit longer to open things when you do it remotely. But here we can see then the information of the specific method that you choose. And here it says what it's based on, if there are any specific implementations done in the software by Prey. And then we can go to the characterization tab up top. And here we then find these factors that we spoke about before when we talked about the difference between relating the effect to the impact, so to speak. So here we have, for example, for climate change, different substances. This list goes on for very long to the right, but then we can also see which factor a certain substance has in this specific method. And you can use these predefined methods, or you can create new ones as well. We'll go into that, but I just mainly wanted to show you here where you can find these methods in CIMA-Pro. For those of you who are new to the software and will get confused when you open it later on, so you know.
Yeah, so those are the characterization factors which relate to midpoint.
Yeah.
And the other section is normalization and weighting.
And these relate then to the endpoint level.
Yeah, exactly. So the normalization is a little bit more objective because it's relating to something that is possible to physically measure. But the weighting as such has to be done by a panel. Or as we discussed earlier, it could also be a political target, or it can be the economic willingness to pay.
And this information of how it's done in each specific method will be possible to find the publications and read up upon how these are done. There is extensive information regarding this to dig deeper into, but here you will have an overview of the specific factors used. Yeah, that's what we wanted to show you here.
So we go back to the presentation.
Let's go back to the presentation, if we can. Yay, it's working.
Okay.
Good. So for the next slide, we wanted to go into the methods a bit more with you and to show you ways and how you can change the methods. Now you know where to find them, but we'll also show you a few ways of how to adapt the methods, but also how to change methods easily in your calculation setup, because for one reason or another, you might want to see how the results vary due to which method you want to use, because there might be differences between them. I guess that you are at different levels. Those of you who have been in SimaPro might already know this, but those of you who are new might see this for the first time. And then we also wanted to show you how you can copy a method and make changes into, if you want to already use what is predefined in a method and just make smaller changes. It could be easy, but you can also create new methods on your own from scratch if you would want to decide perfectly on your own each factor. So we'll guide you through these different things. So we start with the next slide. And in SimaPro, we work a lot with calculation setups, which is that when you perform a calculation of a process or of an assembly or of your life cycle, we usually save that, and we can show you through this slide on where to save it. But you will get this this view when you want to analyze something. So then you can name whatever it is that you want to analyze. And for here, we made a comparison between different sizes of a lorry transport. And we also like to name the method that we use for this, which is a recipe endpoint. And as Marcus is shown here with the arrow, you will be able to decide then upon which method to use for this specific calculation. Below the methods bar, and then in this row, you can double click and choose another method very easily. And if you have saved this setup, you can open it and just change the method very easily, instead of going through the entire setup of putting together the analysis again and assessment.
Sure. Do you think I should do that now? Or?
Yeah, maybe. We'll jump a bit back and forth. Let us know if it's too confusing, but I think it's good to see this on a slide and then just show you where to find it in SimaPro so it's easier for you later. So
we were here, and I'm gonna close this window, and it's a little bit tricky here because closing SimaPro is very close to closing the specific window. So you have to be careful there.
Yeah.
And then we find the calculation setup just after the methods. So here's where in SimaPro you find your saved calculations. You can also do calculations without saving them. And as you can see here, they have the names of the calculation setups are made in a certain way. So that's in order to keep track of what we are doing. The first we use the name of the product being assessed, and then it's followed by the name of the method used in order to keep track of it. And usually we create one calculation setup like this first one here, bike CED. And then we make, when we are ready with that calculation setup, we take a copy of it in order to use the similar calculation setup for the subsequent methods.
Yeah. So here you can find then the calculation setup. So if you open that, you will see which method is used in that. So, and you can easily change them by double clicking. Maybe we can open and just
maybe the one we had before.
Yeah. So here we have the method as we open here. And if we were to double click on the row for the method, we will get a list of all of the methods available to choose from. So here you can easily change them. So as Marcus said, we copy. When we're done with the setup, we copy that and we just double click here to change the method. That is very easy way to assess a product using different types of methods.
And now that we have it in front of us, we can see that there are 3 different versions of midpoint with recipe, and that is actually 3 different weighting systems. Let's see if it says here.
Come on.
Whoops. Yes, so we can either choose a European perspective for the normalization or a world perspective. And we can also choose the three, I have to enlarge this. There are three different perspectives on the safeguarding objects, how we weight them in relation to each other. And that is called hierarchic view, which is based on what the society as a whole think of a problem, how we value damage on a safeguarding object. And there is also another one, the one with an E in the end. Let's see if I can, this one. So this one is, oh, it's no longer supported actually, that's true. But it stands for egalitarian, and that is a perspective that consider both the societal perspective, but also the individualistic perspective. So from an individualistic perspective, it is much more important if someone close to me is affected by a damage than if someone in another part of the world or in another type of environment is being damaged. So that is different value-based systems.
And they will, of course, affect the factors and how it's weighted.
Yeah.
So.
And basically, this is very complicated, and most people using LCA results will not be possible to comprehend that. So there has been a common move in the life cycle community away from using different versions of this, so that we all use hierarchic perspective. And that when I say common, it's mostly guided by the European Commission, because we want something that is more comprehensible, but also possible to communicate. So,
And also comparable in the end.
Of course.
Yeah.
In a way.
While we're in here, we might as well go to the methods as well, because as we showed, you can easily then choose to change the method here in the setup. But as I mentioned previously, it's also possible to create your own methods and to edit existing methods. So I think we can go to the methods tab to just show you how this could be done very briefly. We go back to the methods that we have. If we want to use an already existing methods to make changes, we can mark this method by left clicking. Let's see if we can move this window. Great. And then we can choose copy. So left click and then copy. So this is how you could use those existing methods. Rename it, of course, to your own choice of what you want to call it. And then we can go to the characterizations tab and change those factors. So let's just rename it now. And then we can go to this, we can describe here in the comments what type of changes we want to do and so on, so that we can keep track of it later on. Yeah.
Something like that.
Something like that. And then we can save it if we want already now, just to make sure that we don't lose it. In Sigma Pro, it's important to save often because there is no go back button. So you have to remember to save every now and then to make sure that you keep track of your changes. Now there's a bit of a delay just now, but I think we managed to save it. I hope. Okay. So let's go to the characterizations tab here. Then we have everything already from that method that we copied before. But here we have the opportunity to add or delete impact categories to the far left there. We can choose to select only a few that we would like to look at. Then we can mark one and press delete if we want to delete it, or we could add a new one. Oops.
Mhm.
So for example, if we would like to remove the water use here, we can left click on the water use. Oops, why does it not? Left click, and then we'll take delete, just as an example. And then it will disappear from this particular method. And then we can also add a row which with an entirely new impact category if we would like. And if we do that, then we can choose which substances we want to incorporate into this. So we can press add and we'll find the compartments of the specific elementary flows that we want to look at. It could be raw materials, it could be airborne emissions, and so on. So maybe we find an airborne emission that we want to include in this particular impact category. We can select that, and then we can choose which factor that should have. For example, if you would like to complicate this even more, there is a possibility to create your own substances as well to add here if you would like. But this is how you could work with methods in CIMA Pro, either building from those that are already existing and changing them, or you can build a complete new method from scratch by not then copying an existing method and instead just pushing new, and then you will have this empty interface and begin to add impact categories to it. Yeah.
And very good.
I can't really see if anyone is raising their hand now.
No, okay. So something that
Dahlia, you see.
yes, okay.
I reckon that there might be some input on this.
Yeah, I wanted to ask it, can I do these changes with the user license, or do I have to have the analytic license?
Yeah,
The
you
normal
need to
user
have
one.
you need to have an expert user,
Okay.
as we call it in the commercial field. But if you are at an educational institution, then you would have to use the PhD version.
Okay, single or the multi version can work as well.
It doesn't matter.
It doesn't matter.
It doesn't matter. Okay, thank you.
No. So as a researcher, you can play around very much with everything. And something that Annie maybe forgot to mention is that when we change a method, we should be in a specific project, which is called method. And now we are actually in a project called CIMA Pro Workshop.
Yeah.
So it means that the changes we made here will only be visible in this specific project.
So there are two levels where you can change methods. You can choose to either create a method that you would like to use in this very specific project, and it's not visible in any other project in that database that you are working in. But if you would like to, as Marcus said, it's very important to know that you could add this, you could make these changes in the project that is called methods, or the library that is called methods, so that it's available in all of your projects in an entire database. So there are two levels of this. Yeah, do it.
Oh. So then I would have to go to File, Open Project, and pick the project called Methods. Open that.
Oh,
okay, and here you would go to the methods and find this one we had here,
you
and do the same thing as before.
Then it will be saved here and it will be available in all of your projects. So there are two levels then which you could implement this into. Yeah.
Okay.
There's another question by Priscilla, if you don't mind, she wants to ask.
Yeah, sure. Sorry.
Yeah, I was wondering if we can, how can we do, if we have it, if we want to import the method from an Excel file, for example, does it need to be written in a certain, very specific way, or?
Yes. Let's see if we have. Yes, you can import a method, and before doing so, someone has to export it from CimaPro, or that is the most easy way.
So that you have the format ready.
Exactly. So say that you want to use this method in another context, then you can mark it and go to File and take Export. Yes, and then you will have it in a format CSV, and it will be readable to CimaPro again if you use that. And you need to include the necessary information here so that you remember the settings, and then you can export it. And yeah, I don't know,
Take
should I
some
do
time
that
here to
now?
read
Or?
Yeah,
Yeah,
I don't think you need to export. I was just wondering, like, because you said
Yeah.
I can create my method from scratch there,
Yeah.
but
Yeah.
maybe it's easier. If it's easier to create on Excel,
Yeah.
instead,
Yeah.
and then import to CimaPro instead of adding one by one. So
Yeah.
then, do I just need to have it as saved as CSV and then in the columns as it shows, or I export one as a model and I follow that, or?
Exactly.
Yeah, so you export one of the methods as a template for how to build it in the CSV file, and then you can import it again.
Okay. Yeah.
That's how I would do it.
And this is where you pick the file. So I can. There is actually the latest import that I did. So yeah, that is how we have been working when adding a lot of different categories. It's a very nice way of using the copy-paste functionalities in Excel.
Yeah, something that might be worth mentioning, actually forgot, when you create your own methods, is that you can copy an entire impact category from another method into yours. So if
Should I show that?
Yeah, show that. So if we open SLU one, where did it end?
It's not here.
Oh, it's not here, of course. Well,
I'm making you one.
let me just make a new one. Or an empty one, you can, if you wish.
Why?
Huh?
You're that copy.
Yeah.
So
Yeah.
didn't say on copy.
And then we can save this and say that we would like to copy an impact category, for example, from IPCC. Then we can close this window. I hope this still works. I found that a while back. We can go to the single issues tab and find the IPCC method. Yeah, open that. And go to characterization. And here we only have one impact category, but then you mark it, you left click on it to the left. So you left click on it, and then you can do Control-C, so copy. And then we can close this window, go back to our created method, SLU. We'll go into the characterizations tab again, if it lets us. And then we'll click add. So a new row would appear, and here we can click Control-V, sorry. And then you will receive everything connected to that specific impact category from another method. So that might be a way when you want to extract impact categories from certain specific methods and combine them into a method of your own. Might not be super obvious always, but it's a good way to work quicker if you would like to just copy paste at some point. Or as you mentioned, Priscilla, work in Excel or CSV file.
Super.
Cool. Anything else that we should address regarding this from your side? Anything that you're wondering about? I'm just scrolling.
No, no, just
Screen is not cooperating.
okay. We cannot see if someone wants to.
Zoom here. Zoom.
Then, Zoom. Zoom.
Not.
No.
You would have to help us out, Dahlia. Is everything okay, or seems that our screen refuses to?
No, it's working okay. We can see your presentation, the change methods and calculation setup.
Cool. Yeah, no questions. Then we'll go on.
No questions till now. I will let you know if everyone is last.
Oh, thanks. I don't know
Mhm.
why it froze for some reason. Didn't let us to expand.
No worries at all. Please go ahead.
Yeah. Cool. Thanks. Yeah. So this is basically what we just went through. How you can copy a method and make changes. So you will have to rename it. This is just for you for a recap if you would like to go through the slides later on. Yeah, we'll just scroll through them. Here's where the factor is, where you can add and delete impact categories. You can add and delete substances. You can change the factors for different substances if you would like.
Yeah, and we didn't mention where to find the list of substances possible to change.
Great.
So if I close that one, we have the overview here. And in the menu to the left, in the bottom of this, we find all the general data. And here is a chapter called Substances. And here it's grouped in different categories. And if you wanted to add something in airborne session, you'd have to mark that and click New. And you can enter one new substance and say which dimension it has and what unit that should be. And you can also add a CAS number, and you can describe what it is here. And normally, I think you would have a lot of substances at the same time. So then you would have to arrange this in Excel, and then you can use append to import a lot of a complete list in Excel. And I cannot do that now because then I would need to lock the database for all our other users.
Yeah, we would kick
So,
out our colleagues.
yeah.
Be the best
Oops.
thing to do today. Yeah. There you go.
Marcus, can you say something about the social issues or economic issues I see there in the substances? Because our impression is that usually we use it for environmental issues, but this is interesting to see.
Yeah. So you can basically create whatever you want here, but social issues included in the social hotspot database is commonly available. And currently I don't have that method in this project, but you can see some of the most basic ones here, such as fatal injuries. So you can measure that by amount in a certain period. And for economic issues, that is something you can add to every part of your life cycle to calculate it can be price-based or cost-based, or also maybe insurance-based, depending on the perspective.
We have a question from Stanley.
Yeah.
Mm-hmm.
Yes, I've got a question. So sometimes I see some people use APOS, sometimes people use like cutoff method. What can you say about those two?
Okay. Yeah, why not?
Yeah, go back. Or
Yes. Then why? Oh yeah, I mean the methods. I
Oh, yeah.
open another project. Take this one.
So your question was regarding the different, for example, at point of substitution and a cutoff in a specific library, right?
Yes.
Can you elaborate?
So yeah, in deciding when to use what, it also depends on the purpose of the how you will use the results, and when to choose this. You have to take into consideration, of course, as you say, when to use it. For example, when you use EPDs, when we do EPDs, then we are bound to use the cutoff system, and then we always look at the flows from almost polluter pay principle, where we see that if a value of a material is at the lowest point for waste material, for example, and then all burdens upstreams of that is allocated to another life cycle, and the processing of it to create a material that we can use is allocated to our life cycle. So that's what you sort of lose in a cutoff system, some upstream burden, but you also lose the benefits of recycling a material, as that also goes into the next life cycle afterwards. While at the point of substitution actually takes into consideration some of these benefits and burdens in a more extensive way than the cutoff library does, or system model does.
So say, for example, the material aluminum, the recycling statistics for aluminum in Europe is included into that model so that you will consider that when using aluminum, it will go back into the system, and if you recycle it, more aluminum will be available for someone else to use. So that is a little bit consequential perspective, I would say, rather than what we are doing in declarations and using attributional perspective, which is more like bookkeeping.
When we use the cutoff, we want to use book. Yeah, so allocation is almost like an in between consequential and the cutoff method. We do not have consequential here in this list.
No, exactly. Sorry. Something maybe worth mentioning here is that there are two different versions of both here. One is ending with a suffix system and one with unit. And that is that the unit version includes a complete network system, a complete model with all the details. Whereas the system version is a pre-calculated version, so it only has like a black box calculation with input and outputs.
Yeah.
Maybe I can show you
the
differences. Yes. So I'm just jumping into one of them here. Take this one. So here we can see that it has inputs from other things in the technosphere, materials and fuels.
Yes, this is a market process we'd have to go into.
Yeah, sorry, this was not a good example. I would have to go
right-click and go to, that is
the next level.
The best function in SimaPro, being able to right-click and go to and directly end up in the process choice.
So, but here we can see all the details of every input here, and we can continue to trace them all the way if we like.
And also when we calculate the results, we can also display these sub processes in the Sankey diagram. We will see how much does the concrete contribute, how much does the copper contribute, and so on. While in a system process, it is more of a black box. We'll look at it as well.
I can open one of the system processes. I take the same one. In this case, you only have inputs from nature, which are actually elementary flows. And further down, oh, it's a long list.
So here, all of those processes that we previously looked at as inputs to the other one, to the unit one, where we had more of a detailed view, they are now summarized into these elementary flows. For example, then summarized as input from nature and emissions in regards to soil, air, and so on, different compartments.
And maybe I didn't mention why we have this. The reason for having this is that the black box system will be much faster to calculate. So when you're calculating large models, you can automatically switch in between those so that it goes much faster. And if you need then doing hotspot analysis and want to go back, then you can open up the more detailed version, so you can actually understand if it's relevant or and what to do about it.
Yes, and that actually leads us into the next subject, but I just realized that it's 12 o'clock, so you might want to go for lunch between. But we've gone through the methods, how to make changes, how to edit them. And then the next step is how to then switch between these different kind of libraries and system models to go through. But I think we'll take that after lunch. If you're okay with that.
Annie and Marcus, is it possible to have like an example about the allocation and cutoff, the difference between allocation and cutoff, like a case study or a simple example? Like we can have it like in the next session.
Yeah, it's included in the sensitivity analysis.
Yeah,
So
yeah,
Okay, that's great. Yeah.
Next session. Great. Thanks for suggesting that.
Yeah.
Cool.
Yeah, if we don't have any other questions from the participants. Anyone would like to ask something?
Or if you have a request of what to focus on, if there are any questions like this that we could take up after lunch, please let us know.
Question, comments, requests?
This one as well.
This one as well. Now we come to the next part, when we talk about more changing libraries in CIMAPRO. And I think we could go into CIMAPRO and show you these things as well. We of course have tried to put them into slides the same way as we did with the methods, but it's the same thing that when you want to change from one system model to another, it's possible to do that within a library. So for example, when you're working in Equipment and you want to compare how the results are affected by switching from cutoff by classification to a point of substitution, you can do that in the calculation setup. So you'll get the same view as previously when we looked at how you can switch methods, but in this case you go down a bit and then you choose which current library you are modeling you're creating your model within, and then you choose which replacing library you would like to use. And this is a way to evaluate how the results will change with regards to changing system model.
So if you want to compare those two answers, you would have to take a copy of the calculation setup because the result will be displayed for one or the other.
Yes.
So should I do that in CIMAPRO?
Let's do it.
Yeah.
See if we can make it work.
Oh, maybe. Just on the wrong screen. There we have it. So, okay. So we do those things in calculation setup. And I pick one here. Just anyone, I think. Yes, take this one. And now I want to change to, maybe I start with the one we started with, allocation at the point of substitution. So that is, where do we have it?
Here.
this one. And I think actually I'm using system models here.
I'm not sure.
I'm not. Yeah, let's see if it works. So, and this time I don't want to change, so I just add the same here. And then I press calculate. And it's a little bit faster now because I have shifted over to working on CIMA Pro on my own PC. So then it's responding a little bit faster. I had to do that because the others are working on the remote desktop.
With emphasis on a little bit faster.
Yeah, it's a lot of data the first time you do the calculation. But then the computer saves
It caches.
the cache memory. Yeah.
But it is important then to remember that for doing these changes, for example, Equinvent has these 3 different kinds of system models that you can choose from. And it's easier to do it within the same library rather than switching to complete other library, because then there might be some difficulties with the matching of process names and product names and so on. So as long as you stay within Equinvent, you can switch from consequential to APOS to cutoff if you want to.
Mhm.
This is unusual still.
Mhm.
Just a quick question whilst the machine is
Yeah.
calculating. So if I need to change my maybe economic allocation factors, can you maybe also show us where to change that?
To change to a completely different library? Is that what you?
Allocation.
Oh, sorry.
Yes, I have to think. Yeah, we can show you where it should be, and we can see how to manage it. Is it a specific set of data that you're working on?
Yeah. It's specific actually to pig production. And there are some ingredients, like for instance, maybe rapeseed that is produced in maybe Denmark could have a different, let's say, economic allocation factor when you compare it with rapeseed produced maybe in Canada, for example. So you need to maybe probably calculate the economic allocation for Denmark. Do you get what I mean?
Yeah, I should have done this in the lunch. We can look into we can jump. Yeah. To be patient. Going faster in the end.
Hi. Sorry.
Hi.
Can I ask a quick question?
Go ahead.
Hi, can I ask a quick question?
Of course.
Yes.
Go ahead.
Yeah. I just joined this afternoon, so I wonder what is the schedule for this afternoon? Will it cover like how to change background data? Like if I want to do a prospective LCA, I want to change like the embedded energy electricity data with considering like the future scenario. Because like probably I use a different type of raw material, that will be a lot. And if I change like how to do it, am I clear with that?
Yeah, it's a very broad question. I mean, it's a narrow question, but it's a broad answer. And we will bring that up
Okay, yeah.
in a few steps.
Okay, yeah, thank you.
Okay, so now finally we have the calculation here for this process. And then we have a Sankey diagram here to see the results. And we can also jump into the table if we like. But it's taking some time, so I'm not close. So, but we can have, anyway, we can have the results here, but we will need to extract them in order to compare them with the next calculation. One way to do that is to go to File, and from here we can export everything basically that we see on the visual screen. So anyway, I'm closing this one now and take a copy of it. No. So this here we have the calculation, and now we want to take a copy of that and change from outputs allocation at the point of substitution to cut off, which is the other version. And then I just change here to there we have cut off. And then when I do that calculation, it will go a little bit faster, and we will have a result that we can export from CIMA Pro and compare outside into different diagrams. So that is a very quick and easy way to have different results from the same LCA model, instead of having to make a copy of the whole life cycle assessment model and change the libraries, which will take some time.
Yeah, that will be time consuming.
Yeah, actually, I have done that a few times for other reasons. But then normally it takes 1 or 2 days to work through a complete set of LCA data in a ordinary sized LCA. So maybe that's good to know that it's possible to do it, but take some time. Okay.
Let's finish that. I'll go back to the slides.
Yeah. Let's see, I just narrow down that window. No, it doesn't allow me. Can I do that? No, det går inte här. Jo, där har vi. Yes.
We'll jump forward.
So what we just demonstrated to you was how to change the system model in a calculation setup. And the next thing we wanted to share with you is how you can actually change the links to library projects. So EcoInvent is one library, and if you want to change to another library or another set of data in the same library, there is a specific function for helping you to do that. And it's found under, or maybe it's in the other. Nice. Oh, first. Yeah, you can find it in the functional menu called Tools at the horizontal top of CIMA Pro. Should I go into that one maybe?
cancel. the
We
screen
just
share.
cancel.
Yeah.
Okay. Don't save. So here at the top, you have tools, and there we can find projects to links, project to library links manager. It's a rather new feature in CIMA Pro, but it can be tremendously helpful. So here to the left, you have all the projects in this database. And currently we are working on CIMA Pro workshop. And you can actually mark all of them here if you want to change everything in all the projects, or you can choose only one. And then you mark to the right here, you mark the libraries that you are looking for. So if you know that you want to change things in a specific library, you can let it be only that one, or you can pick all of them. And for example, I know that we have an old library here. So maybe I want to know if I have some items in my project that is pointing towards this old library. So then I click on that one. And down here, I can choose a scan to do the calculation and find all the links.
Let's try. No, that's good. Oh.
So here it was actually very fast. And here I can see that I have a lot of links to this old data set. And that is natural because I was using an older database now. So say if I want to change one of those, then the first column here, it says what project it is found in. The next column tells me what category that I would find it in, say parent type. So it can be material-based, an assembly of different materials, or it can be a waste scenario, or a waste treatment, etc. And then it tells me the parent name. Oops. So that is, for example, in what set of data is it that I'm using this link? And then I have the name of the library. So I was looking for now eco-invent system processes. And then the child or the incoming process to this one has a certain type, which is a material. And then I find here that I'm using a packaging glass green. So, and I will narrow the columns so that you can see the rest. So what I want to do now is that I want to replace this packaging glass green with something else. And then I click in the column next to that one called the replace name. So I double click, and then I get access to everything in my database. And I can search in different ways, but now I wanted to shift from one library to another. And the name of the library is in the end of the row here. Under it's called project because a library is actually a project. So here I can see that this one is using
I just happened to be the one that was marked.
Yeah, it just happens to be the one that was open.
So we'd have to find the glass here. We would like to replace the link to.
Exactly. So
let's say that we'd go to glass and find the packaging glass green within the set of the APOS
here
library
we have
instead.
the glass, packaging, transformation. And here I can find something that is more up to date. And we were looking at the green one.
Mm-hmm.
So actually there is, it's a little bit too big here, but how do I reduce the size? Can I take that?
Okay.
I can.
Impossibles.
Impossible. I want to reduce the size to reach
Original.
there's a search function here in the bottom that I would like to use. Do you see that? So if I know that I'm looking for glass, I can print glass here, and it will help me narrowing the list down. And I can also choose to look for green glass. Then I see only the green options. And then let's pick, for example, here the abbreviation is Switzerland. So maybe I want to use that. So I take just one at the top here. And I select that one. And now it tells me that, oh, it's actually 2 links in this long scanned list for the project that refer to this one. Do you want to change both of them? Yes, of course. And in that way, I can find a lot of data at the same time, and it's very convenient. And when I did that, I can go back, I can click replace here, and the replacement will actually occur. So now it says that we have replaced this in the LCA model as such. Was that clear enough?
Yeah. So, but I guess if I understood your question correctly, you would like to change a set of electricity data in your model. Yeah. So this could be a way for you to identify that specific set of data for electricity and then change it all over if there are several places in your model that you would like to change it. Maybe this could be a way for you. That's one tip from us.
Exactly.
Otherwise, you could, of course, go through your model and try to change it by hand, so to speak, in your model. But if it occurs in many places, this is a much faster way because it will identify every point where it's used in your model, and then you can change it right away.
And especially when you have made a major update to a new database, there will be some data that is no longer it's not being updated in the new database. So you have to choose another set of data. And for most of them, this is actually something that can be automated. So when there is an update, pre-sustainability produces an Excel list with those, they call it replacement files. And then it's possible to import such a replacement file here. Import replacement. And now it appears on my other screen here. So I move that to your visual. And then you see here, it's called replacement files. So here you find those. So there's a long list of replacement files. So then you just pick one of them, open up, and you can import the replacements. And now I didn't have any because I already did this. So yeah, so it creates an error message for me because I already did this.
Yeah.
So I'll just close that down not to confuse you.
But that is good for you to know whenever you do updates of your software in your database that these files are automatically included because they know which ones, for example, equipment data or any other library, which processes that have not been updated and that are now obsolete and should be exchanged. Then they produce this automated list to exchange them for you. Of course, it could still be some that are left, but when you do a calculation of a model, you will always get messages before displaying the results that you have obsolete processes in your model, and then you can find those obsolete processes through this tool. But use those replacement files whenever you update, because then you reduce the risk of having obsolete processes in your model.
May I have a question here? Yeah, like for example, if I also want to change the electricity used for like the first line clay, how can I do it?
Okay.
Yeah, that's another question, but we can do that actually.
Okay.
So
Let's go to processes. That is if you have a material and you would like to adapt it by changing the energy source or anything like that. If
Yeah,
you have
sorry to interrupt. My
No.
thing is like I want to change like the electricity source for all the raw material like that. Do I need to do it one by one or?
I'm afraid you might have to
Okay.
if you or is it possible?
you would have to open the, for example, now clay. It's part of the project called EcoInvent. So I would need to open that project. So I go to here, File, and Open Project, and open EcoInvent project. And then you can do the same thing as we did before with the tool projects links manager, and you can actually change everything in that project. But then you actually make a very big change in the background system. So I would recommend you to take a copy of EcoInvent before you do that.
So after I replace everything with a new how do you call it? Like after replace, so there's no chance to go back.
Yeah, that will be, you cannot just rewind. No, you would have to remember what you did and reverse.
Yeah, if you choose to change it in the entire.
Exactly, and of course, before you make such major changes, you can also take a backup of the complete database, so that you can always do that from here, database backup, so that you can always rewind to that. But first, when you asked this question, I thought of a more simpler way to make that kind of change for one specific process, like this one. So say that you want to regionalize this, change it from now it's for Switzerland. Maybe you want to make it suitable more for Sweden. Yeah, so then you can take a copy of all that data set and you can rename it here. Sweden, SLU, just to know what I'm doing. And then I go down here and change the environmental aspects that I think are most important and have something to. Do you know how to do this? So say, for example, that I want to exchange the electricity coming in here. Oh, typically there's no electricity. But I can just change one of those data sets. That one will probably be important. So then I just double click and pick another one that is more suitable in this context. Oh, that was a bad example, but I can just pick anyone.
Yeah, I understand.
Yeah.
Yes. Thank you. My question was like more like changing all the electricity usage along the production chain. It was more, it's more complicated, I guess. Yeah.
Yeah, so it's a little bit complicated when we have to do with libraries. But if you have data that you created yourself, then it's easier. So let's see. For example, I have my project here with a bike. So here in one of those models, I have a bike and I have the frame. And inside the frame, I use electricity. So I open it here. And here's input of material, and I could as well have had electricity here. Let's see, it's energy, electricity by country, low voltage maybe, market, and here I can find the one in Sweden.
Just
In the very top, of course. So, oh. Wow,
Now
it doesn't want to
keeps
stop.
going.
So, here we are. It's a lot of countries for electricity. So there we are. So I just say that I have one here. And if I want to change, if I have been using the same type of electricity throughout my model, then I can find it in the projects to links libraries and exchange all of them. So then I'm not restricted by the library in Equipment. So that is super convenient. In most projects that we do, we model everything ourselves from scratch, and then it's actually very convenient to change in this way. Okay.
So you could do it in your model by using the tool. Yeah.
Exactly. Yeah. Okay, I forgot where we were. So here we have this one. That was projects to links manager.
Yeah, that was it. I think then we should show. We did show how to do it.
Exactly. And this is what an error message looks like when we find obsolete data. So then you can just see that, oh, the name of the obsolete data is waste electric. And then you can find that set of data via tools and projects to links libraries. Projects to libraries links.
It's hard to say.
Yeah.
Yeah.
Okay.
That's one way to use it. Yeah, and this also connects to actually how we worked with the methods before when we showed you how you could create them from scratch if you want. And one way where we actually use this feature is when we have tried to incorporate already existing EPD results into our models. When you, example, read an EPD and want to include those results. So what you would have to do in that case is that you add new substances for each input of those results, and then you create a standard process for that EPD import where you use these substances, and then you use it in all projects. And then you also have a method where you add these substances into the correct impact category so that they are picked up in that method. And it's a very, very convenient way to use EPDs. The thing that you have to take with you is that as you create your own method, it's not automatically updated whenever Prey and Sustainability do the updates of the methods in CIMAPRO. So whenever the software is updated and it includes updates of methods, you will have to redo this for your method as well, as it is still locked in order to not mess up anything that you do. But it also automatically that means that you would have to redo it again. But they're working on trying to find a way around this. But this is something to keep in mind when you work with these kind of things.
Mm-hmm.
So this probably should have been with the methods section, but I think it came a bit far down this slide. But then
Okay. Do you think we should show it in CIMAPRO, or
can we? Let's do it.
Yeah.
Just as an example of how to do it.
So there we are. So what Annie was saying now is the first thing you would need to do is to add those new substances, the results in an EPD will have to go in as substances. So we create them here.
Yeah.
And it would have to be an elementary flow, such as raw materials or emissions.
So say that
Yeah,
an
one of
airborne
those.
emission could be like GVP from EPD and not something. You can name it like EPD first to know how to distinguish from those. So then you could have GVP. In whichever way suits from the EPD that you're using.
Represent results in EPD, for example. So that is something that is pre-calculated.
And now it appears as a new substance. So whenever we want to include that in the method that we wish to use for our, there it is. Oh, we have everything.
Yeah, so we have already done this for a lot of things.
Yeah. So then whenever we go to a method, maybe we have the method when it has those incorporated.
So this is, don't remember, I think it should be here.
We have created a new method then as before when we copied an already existing method that was in the library. And then we renamed it. And if we open it, here you can see that we renamed it. And then we went to the characterization list.
First, we can say that when we create a new version of an old method, we always add a log file here to explain what we have been changing.
Yep. So here we can then see that for each impact category here, we have added the substances that are named EPD input something.
Try to find it. Here we have one.
Yeah. So in this fossil, we have, for example, the EPD input climate change, and that is the new substance that was created, and we have added the factor with which it should be added to this. And for all of them, it's 1, simply because we want to be able to put in the same amount that is present in the EPDs. Yeah.
So for acidification, we have the same thing. Let's see.
It's at the top.
EPD.
No.
It should be here.
There, in the middle.
Oh, there
The
it is.
input acidification. There we have the one for acidification, for example. So here we managed to add then those substances to these impact categories. So whenever we use this method, it will pick up the inputs that we add. So to combine with this method, then we also created a standardized process.
So see if I can find it.
Yeah. Maybe just have to search.
Yes.
Unless you know where it is.
Yeah, now this is another thing. When you're looking for life cycle inventory data and you don't know exactly where to find it, in which category, then you can click here to the right. It says show as list, and then all the categories will disappear.
And instead you get an extensive list of all processes available in this, in all of the categories.
And then I can find everything named EPD. So you can see that we have a template, and then we have a few processes that we have built based on this template. So if we start with a template, here is all the things that we, yeah, it's actually an old version now. So I don't think I have the correct version now, but the names here should also have the substance names should be the ones starting with EPD.
I'll try the other one. Just to data.
It could be this one. Yes,
think it's
here
the
we
one.
have it.
So here we see all of those substances that we added, and here we've just included them in a standardized process so that you can copy this and then add results from an EPD in each corresponding row. And then we know that since we made a method that sees these substances, that collects these substances as well as the other substances already present in those impact categories, you will know that it is caught by the method, and you can use this. So this is one way of utilizing the possibility to be able to create own substances, own methods, and also combine it with the process to standardize the way to use EPDs, as an example.
Yeah, we're getting into details now,
Yeah.
but we wanted to show you everything about everything.
Turns out it's quite hard to keep it contained.
Yeah. But we continue with the next section. Yeah.
Interrupt us anytime if you have any questions or if it's anything that you want to see more in detail.
So basically, we have been trying to follow this chronology in LCA projects, that we start with a goal and scope, and then we collect the data and build the model, and then we do the impact assessment, and then we need to do some interpretation of the results. What does this actually mean for us? And some of the important steps here include sensitivity analysis. We can do scenario analysis, and we can do uncertainty analysis. And we should also identify potential improvements so that we can make a recommendation based on what the findings. We are following the ISO standard about this, and they address those issues. Recommendations, or it's not 100% perfect here, but we should say something about what is the most important, and something about the completeness of the LCA model, how sensitive it is to changes, and how consistent it is in terms of choices such as allocation, such as background data, such as what we have chosen to include, and things like that. There is a description about this in the ISO standard, but these are the main headers of that. So I'll start with one of them, sensitivity, and related to uncertainty. And normally when we do an LCA, we do not have very much sensitivity in the data. We have things that we can do is we can make a choice of what library to use, and we can choose different processes. That will be important, but there is not very much variation inside the data normally. Things that are also a reason for sensitivity is typically the assumptions we make, such as whether or not to include transport, for example, whether or not to include infrastructure, if we should use, maybe we make an assumption about the end-of-life scenario and things like that. So by changing these assumptions, we can see how sensitive the results are to that change. And one way of describing that sensitivity is to compare the results so say, for example, that you change one assumption with 10%, and then you see if the results changes with 10%, then you know it's a 1-to-1 relationship. or if you change the assumption with 10% and the result changes with 1%, then you know there is a little effect on the results by that change. You can also test the sensitivity to the impact assessment methods. Sometimes there are different methods are not equally equipped to handle different questions. Normally, global warming potential is very similar throughout the different methods. But if we go into toxicology, for example, there can be large variation between the different methods. So if you're looking at something that has a lot of toxic effects, it can be interesting to try out different methods and see the variations. And then, of course, you should explain why these changes occur. We also have missing data. Of course, we don't know everything about everything in the model. So we would have to describe that and identify the potential difference in the results based on that, which can be very difficult, I would say, but at least we have to address it. Uncertainty includes more issues like reliability of the input data, for example. How if we have the consumption of something in the LCA model can vary within a scope, then you can actually include uncertainty data about that. And if you have that, it's possible to calculate the effect on the overall results. So the eco-invent data include this kind of variations. But if you create your own data, it's very common that this is not included. So therefore, I would say that uncertainty information is a bit more limited in LCA normally. The sample size, of course, is important for that. So you would have to make a statistical model to understand the importance of the sample size. And you would also need to test for representativity. If you have one data that is not very representative, you may try out many different alternatives and see in which scope this results can vary depending on the choice you make. You can also make geographical variations. Maybe you put up a scenario where you choose electricity, for example, from different regions, so that you can see how that has an impact on the overall results. See, I'll think of what do we have on the next slide. Yeah. So, for example, we have when we're looking at the bike, we made a very simple scenario here, so that we inside the same calculation setup can vary the parameter for the weight of the frame. Let's see, in this case, we have made a variation here from, we changed this parameter for the weight frame to from 4 kilograms and tried it with 5 and 6. And I'll show you how to do that in the model.
So when you want to do these variations in your model, it's wise to use parameters as a way to incorporate these things in your model, for example, the weight of a certain component and so on, because it enables you to find this parameter later on and vary the amount. So you don't have to go back to your model and, for example, for the frame, if it weighs 5 kilograms, then you don't have to go back to your model and exchange the number 5 to 4 to 6 and then do separate calculations for this. Rather, you can use this parameter for the weight, and then when you go to your calculation setup like this, you can, through parameter sets, then find this specific parameter that you want to vary, and then add new numbers here, and that gives you a span in the results. So it gives you several different bars in your diagram where you can see how this affects your model.
And so you added the different things you want to compare, give them a name, and then you add the parameter by clicking here. And it runs through all your model. So you have to pick your parameters here. And
this list can be empty the first time you do this, and then you click scan 3, and then it will take some time, but then you will have all of the parameters available in this particular model.
And they are listed by name or by type. So here we have project-based, but they can also be, let's go up here.
Database.
Yeah, they can be on database level, and they can be at product stage level. And you can also find them per project, if you like. Now I have been using the same database for almost 15 years. So my list of parameters is quite extensive, but when you start from scratch, it makes sense to find it in that way. All right, so now I have picked one parameter to vary, and I would advise you to take one parameter at a time. You can take many parameters, but be aware that the variations possible will grow exponentially. So that becomes easily rather complicated. So it's more possible to interpret the results when you have only one parameter. So I do a calculation of that. It runs through all the possibilities, and maybe we have a picture of that.
Yeah, we
instead.
have a picture of the finished results in the PowerPoint. Next slide.
Yeah.
Sorry.
So then we can see per impact category, which is in which category does the result change a lot. And I
think this is an old project.
This is an old other project.
Might not be super representative of. But
But
anyways, here you get these 3 bars for each of the impact categories, so you can evaluate how the variation in the parameter affects the results on your own. So it's a good way to assess the sensitivity to different assumptions, for example.
Okay.
Yeah.
So and let's jump back to the. Okay, I have to push that. Oh, cannot change window. Let's. Hey. There. Hey. Doesn't want to change window.
No.
No. Okay. So here, for example, when doing this calculation, it shows me that one of the processes is obsolete. So I should exchange that. So I just save this information for later with the store function. Oh,
We
my
have a minute left until.
I've got a question.
Yeah. Go ahead.
Yes, so when you talk about uncertainty, what kind of uncertainty is this? Is it local? Is it global?
Depends on the data set. So uncertainties can be regarding the allocation. Then it has more to do with a complete model. And if it's an uncertainty about an emission, it will be more local. So you can actually look at different kinds of uncertainty. Here is the result from the calculation we made with the different results here. And maybe we should jump into.
We have a few examples of different types of sensitivity that we wanted to show you on the slides. So I think we can go through and just to have a discussion around what types of sensitivities there are. And then we could go back and forth to CIMA Pro to show you if there's anything that you feel that we missed that you want to see in the software. However, it's 2:00 now, so I was wondering if you'd like 5 minutes just to catch a breath, or if we should keep going.
Okay, say that we want to change those we want to change to a different model, and then we can calculate the results from that and compare like we did earlier. And then we can put the results next to one another in a diagram, and we can see the importance of background data set. So here we can see that for end of life, the two at the top here, there is a great importance, of course, because in allocation at the point of substitution, we actually avoid using a range of metals and other materials. And in the use phase, it's not as big difference. But we can still compare it and see what parts are contributing to a difference. We have a significant variation in the raw materials as well. So I think this can be interesting and relevant information for the sensitivity analysis.
Yeah, if you want to vary the system model that you use to calculate to see how it varies depending on the choice. This is a way to illustrate that through CIMA Pro, and that's one way.
Yeah. The other thing was if we wanted to change the method.
Yeah, for example, from the environmental footprint to recipe or IPCC or anything, to see how variations in those methods affect the results. Then it's easily done in the calculation setup, as we said before. And then you can export those results to see, and then create graphs to see how that happens. And it could look something like this.
So this is an example of that variation.
I think.
Yeah, I have a question, if it's okay.
Yeah.
Can you go back to the slide, previous 2 slides?
Yeah.
One more? Yeah, this one. When you can see there's a huge difference between the cutoff and allocation in case of the manufacturing. And also end of life, well, it's a big difference in the result. So some are positive, some are negative, and when we interpret this is a big difference. Why do you think we have this difference here?
I think they relate to the same issue, that we have avoided production of metals in this case. So even in the manufacturing, we have metals sent to waste treatment, which is recycling. And if we use cut-off, we will not have any avoided production. But if we have allocation point of substitution, we will have avoided metal production.
That's in this specific case for this specific model. And when you receive these type of results, of course, as you say, you want to start investigating what is the aspect that contributes to this difference. And it can vary depending on what you are investigating. So you'll have to go from here and then dig deeper into what is it that generates these results in those two methods to find, as you are after those answers, and that you can explain, as Marcus said, that it is the recycling of metals that we know in this case that has these different approach in these two versions of the library, that we have different system models that treats these aspects differently. And then we know why this affects our results. So that is one way to use CIMA-Pro in order to change these system models and see why is it one way or another. And you as researchers, when you read up on how people other articles from other researchers and so on that present results, then you can have this knowledge with you and as a way to help you navigate through their results as well, see what implications it could have.
Yeah, exactly. David, you have a question?
Yes. I guess my question first, before I ask my question, is, can I ask a question more general, or do we have like a program now for the rest of our time today, or that we have to cover, or can we take these kind of questions that I have now?
Yeah, we have. I was planning to show a few slides about Monte Carlo analysis. And then
that's about it. We have a few more examples left, two more examples on this topic, and then the Monte Carlo. But if you want to change the agenda a little bit, go ahead.
Maybe I ask my question, and then maybe we can do it at the end, or you can think about it. From a new user perspective, I've seen many examples, and I've used the software. I mean, I observed the software. I've opened it. I've looked at tutorials. And it always seems like there's a lot of depth, a lot of detail, which is important to come back to and to remember for the future. But I guess my question is more about approach. As I'm starting a project, I want to have some kind of basic model, LCA model. How do I start? Because I've only seen existing examples. If I start from zero and I want to have some kind of result that I can build on then and optimize throughout the life of the project, what do I do when I open CIMA-Pro, and what is your approach? Could you describe it in sort of 5 steps so I could write the steps down? Like, because
definitely.
There's so much detail, which I think is very important to come back to.
Yeah, I think that Anja and I, we were like, now we have a course for researchers. They are super advanced and looking for all the details. So we actually skipped the more basic part with how do we get started in CIMA-Pro. But we can definitely use a few minutes in the end here to show a little bit of those steps.
To get you started. We also have exercise from one of those basic courses, like an example that you could use that we can send to you afterwards as well.
Yeah, why not?
To guide you through when you have the software and when you start to build your models, so that you have something to look at.
You mean sending out like a PowerPoint about those?
Yeah, we have a Word file with an exercise how to build this, and then you can start. But we'll take some minutes at the end, and then we'll also try to help you get some material to get you started in CIMA-Pro during the trial for the month.
Yeah. Okay, the next we were at that slide, and then another way of looking at the sensitivity is when you already have found out that electricity is important, for example, in your model, then you can calculate it with a different type of electricity by using this parameter sets as well. And in this case, I was looking at a charger for vehicles, and if we power that charger with water power or with the Swedish market mix, or if we use the Nordic residual mix in the electricity, we have a significant difference. And so that can be a way of visualizing the sensitivity to electricity. Another example from the same project was if we have an electric vehicle with electricity from a specific company, in this case Mälarenergi, we can try it for plausibility. Is these results reasonable? And that one way of doing that is to compare it with other data that we have access to, for example, in EcoInvent. So we have an electric vehicle in EcoInvent, and we can also compare it with a combustion engine in EcoInvent, for example, just to see that it's reasonable, basically. So that's one way of working with plausibility. I think plausibility is actually rather difficult because there is not so much around to compare with that has the same model, goal and scope and things like that. But yeah, at least we have something. So the next thing that we had some question about earlier, and that is interesting, is Monte Carlo. We use that to understand the uncertainty of the results as an effect of the uncertainty from the input data in the model. And EcoInvent comes with a lot of variations in input data, mostly statistical based. But it tells you something about the variation. And in the top horizontal menu with the functions, we can find this symbol with a diagram that is used for the Monte Carlo calculation. So you pick a process or a model, and you can run the whole LCA model for that. So you just click on the icon for Monte Carlo analysis. And
what happens is that a view where you get a new calculation setup appears for this Monte Carlo analysis that you can, as before, save, of course, by putting in a name, and also choose the method with which you want to do this Monte Carlo analysis with. So a tip is, of course, to use the same one as in your other calculations.
And at the bottom of the calculation setup, you can pick some calculation setup for the specific Monte Carlo calculation. And a typical calculation would be that you run the calculation 1,000 times with variations randomly along the possible variations for every input data. And you can actually add a stop factor if you know where it's not interesting anymore, if the result goes beyond a certain figure. And you can have a seed value if you like to start from something. But the normal setup that we use is this.
Usually 1,000 runs is the one that we use.
Then, needless to say, we are not experts in Monte Carlo analysis and statistics, but there are lots of possibilities. A typical interesting result in this is if you have for the endpoint you can see that per impact category, we can see the spread in the results. So for climate change, we have the largest span. And then also for terrestrial acidification, we also have a large span, and also for particulate matter formation. So it tells us something about the uncertainty per impact category. And it also tells us something about in which impact categories we have data about uncertainty. So I think it's important to make a proper interpretation of those results. The next slide is we can also get this out in terms of statistics. And for me, the most interesting factor here is how big part of the results input data actually has uncertainty data. And in this case, it's very big. It's 71.4%. So it's a lot of the data that actually has information that is interesting. But I would say this is not very common. It's a bit unusual. The next one is after running this with the endpoint, I think it's important also to do it with the midpoint scores. Now I have also normalized this. So in order to see if the magnitude of variation is important to the final results. And then we can see that for the final results, it's actually more interesting with ecotoxicity in this case.
Mm-hmm.
So that was just some possibilities with the Monte Carlo analysis. And if you made your own LCA model with a lot of specific data, you can have very specific variations in the input data and calculate the variations of the results based on that. Can be super interesting.
Mm-hmm. Yes.
All right.
I think that was yeah.
Yeah.
Back to this.
This slide is to sum up a bit. The interpretation that we do as a part of the life cycle assessment includes those phases, and they are fairly important, or very important, I would say, especially because we need to arrive at a result that someone else can understand. And from my experience from working with LCA for 20 years is that this is a weakness among in our community. We are not, this is not our strongest side. So I think we need to work more on the interpretation of the results normally. So we are trying hard with that in our company.
And being able to communicate those as well.
Yeah. And also to sum up what we started off with is that in order to create value with LCA, we can use the results to improve a product or a process, and we can also use it to manage a production chain, to find improvements in our work, and we can also use it for communication. Nowadays, mostly environmental product declarations, but also sustainability reports and externally on the web page and things like that.
And for you as researchers, of course, to evaluate new processes and new systems, and being able to communicate those in these articles that you publish as well. So this might be more of a standard slide from a business perspective, but of course we can tweak them to your environmental perspectives as well, or your educational. But let's go to your question, David, unless there's anything else that we should pick up regarding to those final slides. Because then we can start, or basically go through how we would start an LCA from scratch.
Yeah. Okay. The first thing we do is here on file. We want to start a new project. Usually you start a new project, and we can call that David, Camp David. So, and it guides you to choose what libraries to include. And we are mostly doing environmental product declarations, and then we use cutoff by classification, both unit and system. And we also use methods.
That always has to be.
You have to include that one. And I think that's usually about it. Sometimes we also use industry data, both these.
Or our own library. You can also create your own libraries with data if you want.
Yeah. But the more libraries you use, the more complicated it is to find the right data.
Mm-hmm.
So it's also nice to limit the amount of data.
That's so easy.
Yeah. And then the next step would be to go to description. And first it has to read all these databases.
Yes, and as we mentioned before lunch, this sort of table to the left, or the rows to the left, tries to guide you through the different phases of the LCA. So now we are in the golden scope where the description tab helps us put down all of these things that we have to consider in the golden scope section. So here you can actually write what is the goal of the study and what is the reason to do it, what type of study is it, and so on. So all of these you can then use later on in your report. And it's also easy if you document here for someone to go back and review this model and sort of read this like you would read an LCA report, more or less.
I don't come up with something smart here, but you can, if you make the proper documentation here, it's easier for you to understand afterwards how you can reuse this data. And you can actually also use everything you write here with if you right click and use copy item descriptor, you can copy this information into a Word document or something.
Yeah, there's an add-on called Report Maker that creates these live links between the software itself and the report. So that whenever it's updated in the software, you can also automatically update it in the report. But yeah.
You need to save every time you go from one page to another. The next step would be to start at, you can go to processes. And here you can try out things that are already available for you. For example, if you want to compare different plastics, thermoplasts maybe, you find them here. Under it can be different markets, such as Europe and global market, or you can find it under transformation to have every specific data set for specific production sites, or statistical data, it could be also. But if we take the market information here, then we can choose to compare a few of them like that, just to have a very quick answer. And you can click on compare, choose a method, choose a method. Now it appears on my other screen. Whoops, like that. So here I have the methods, and I can choose one. And I can calculate that. Oh, sorry. Run that calculation, and I can easily have something interesting to start with. So with just a few clicks, I can have something to analyze. And normally when we do LCA, we start with product stages and we go under assembly. That's where you put the product together. And we add a new one here. And I can take a car. So I put the name of the product. Car David, maybe. And then I pick some materials in the list. Maybe I have some metals from the market. I want to have some iron. And the abbreviations here is for different markets. So this is Europe. And then we have global, etc. So I can take that one and I say how much I'm using. Maybe so many kilograms. And I need some kind of process to process the metal into something, a component. And I find the process is energy, and then processing. I want to treat metal, and I find it under metal. And here is shipless shaping. Strange word names maybe, but these are typical treatments of metals. So here we have steel, drawing of steel, for example. And how much do I need to use? I think I need at least as much as we are using as an input. So that can be valid. We can also use this status function here to remember how far we have come on this data set. And so far it's just temporary. So this is the most simple LCA modeling, I would say. And the next step, if I close this one down, I go to life cycle. And here I can create the life cycle for this product. So life cycle, car, David. And here I pick the assembly which I created. And how many of that? 1, maybe, or 100. And then maybe I have some processes here that goes into the life cycle of using this car. Maybe I need some fuel. Why don't I there? Fuels. So fuel oil, maybe diesel. I don't know why I don't find the correct ones now. Help me out.
Because it's, I don't know.
Processes.
Seems odd.
Maybe I need. I need mechanical energy from fuel instead.
There.
Sorry. So here we have some burning of fuel in one vehicle. Here are some other. So if I can use diesel burned in a building machine, it's not very representative, but
Let's just go with it for now.
yeah, maybe we can use it now anyway. So how much energy is used during the life cycle? Maybe it's 345 megajoule. And then I can add a disposal scenario for this car. And an easy way out is to choose one ready-made waste scenario for, say, for example, for Netherlands, that one was
Those are
empty.
not available anymore. They're under incineration.
Yeah, they have moved. So here,
I think, not too sure. We moved it.
so here we have if the car is going to incineration, it can also go to municipal generic treatment.
Yep.
And maybe it's in Sweden, so I can sort it by Swedish. And then I have a scenario for that. And here I can also add additional life cycles. If I, for example, need some extra tires during the life, I can add a life cycle for that as well. But then I have to create that life cycle model before.
So a good way to start is usually to almost draw it on paper before you, so you see what is it that I'm to assess and how does the life cycle look like. So you know, and then you start building your model. And now we made it really simple in the assembly by just putting together a car. But the benefit of modeling in assembly is that you could model each component of the car in itself. So you could model the tires, you could model the chassis, you could model the engine or whatever, and then put them together into a car. So when you go to life cycle level, that's basically where they look at which assembly are we looking at. We're looking at the car. So that's at the top here in the diagram. And then what you do in the disposal scenarios is that you could break it down potentially into those different components again. Here we just have one component, which is the car, but that is a benefit of using the assembly. So there are some different ways of modeling it, but this is a simple model to start with. And I understand that this is very tricky to follow because it's very fast now. We usually go through this over a significant longer amount of time so that you can follow this easily on your own. But we'll try to provide you with an exercise that helps you through these steps so that you can sit on your own in the software to model. And if you have any questions.
Yeah,
Pardon?
a comment. So this is exactly what I was looking for. So so it's very powerful to create some kind of model right away using existing data, and then for especially in academia where you have perhaps some kind of new process, then you can supplement your own data into existing data and tune the model.
Yeah.
So it looks very powerful.
It's something that we usually do is that we say we start simple. You can start like sketching your model with general data. And for example, for this pig iron, if we were to collect more specific data from a supplier, we could create a data set of our own and replace that data set with that so that we have more information. As you say, you start with general data, start simple, and then you add on with your information the further you go. But you can easily and quickly build up a model based on what's existing in the database already.
Yes, and there are hundreds of different variations of analyzing the results now that you have it here. The Sankey diagrams is like an overview, but you can also dig down to the details with impact assessment. So you can see the results in figures or in diagrams. And you can dive into specific inventory items. You're looking for all compartments or specifically raw materials. Maybe what is contributing the most to fossil, maybe, or biogenic if you have that. And you can cut off everything that you don't want to see. Yes, and you can analyze the process contribution to see which data is actually contributing the most here and where it comes from. I think that's a nice way also of understanding the results, because sometimes one set of data can be in the wrong system model or something. Yeah. Okay. What else?
Yeah, I hope that gave you a quick insight into what you can do quickly in SimaPro. That it answered the question.
Yes, thank you. It's very good.
Okay, we have 15 minutes left, actually. I didn't.
I wasn't
hardly
planning on
believe-
this. This is not common for us. We usually cram so much into these sessions. But maybe we can just have a discussion around any questions that you might want to ask now. If you have anything on your mind, the floor is yours to ask.
Yes, may I ask if you hear me?
Yeah.
Yeah, I was thinking about the methods that you said you can create your own method. Actually, methods in LCA have to be some standardized and accepted methods. Why do you, suggest that creating our own method from scratch? That part really I couldn't grasp. How can we create methods? Maybe, yeah, I don't know if I couldn't understand. What do you mean by that?
Yeah.
I mean, the methods are standardized already there. We have to choose. But how can we create the method?
For example, I have created a method here for circularity indicators. So I started from scratch to give it a name and adding some parameters, impact categories here. So this is super basic. One is called linear flow index and another is circular flow index. And then I created some substances to go with it. And I could use these substances inside my data. So in order to use this method. As Annie showed us before, you can also copy from other methods so that you can make your own method from scratch.
That is what bothers me, because if you copy from others, which is standardized already, it is just to create our own new file and not creating the method actually.
Yeah.
Yeah. No, that's right.
Yeah. As you say, the methods are very much standardized and they are like accepted in use. The thing is that when I say create a new method by copy from others, of course, I'm not changing the factors in that. I'm just collecting that I would like to use this impact category from this method and this impact category from another. An example is when we were doing EPDs, there are sometimes specific impact categories that you have to you have to provide results for, and then those impact categories can sometimes be that you have to use these ones from the CML method, but these ones from the recipe method. And then I would create my own method, but where I basically just summarize those impact categories I copy from the other method so that I can easily in one run get all of those results.
The calculation or the assessment approach that we are using, but the method, actually, the basic method of LCA is not used. That was I have understood. Maybe when we say creating a new method, it may have a different interpretation. So in that case, yes, it's possible to the new directory or new database to my data from different methods, existing methods. I am not changing those methods actually, but I may deposit or create a new directory to then I use that one when I run my project. So the terminology when you say creating your own method have somewhat different.
Yeah, of course. I understood that it might be a bit confusing. That's just the terminology in SimaPro. I had to create a new method, but you can create completely blank ones as well, as we showed, like as Marcus say now, you can start from scratch and just completely make up how you want things to.
Yes, in that case, I may not.
But the use of it might not be. It might not be useful to you.
Yeah.
Priscilla, can you share your comments, please? You have 3 comments in the chat. Can you share us with them, or with us?
Yeah.
See, chats.
Oh, you can't talk. Okay.
So
Priscilla, yes, she had some comments about this. She said that you can use these methods if you just want a few categories, or if you want to add another method that is not there, such as the planetary boundaries, LCA. And you can create a new method as long as you have data for it.
Yeah, exactly. If you have data and you have characterization factors and so on that you already know of, then you can create a new method, as Priscilla says here.
And I think that's really interesting when you get behind the methods of life cycle impact assessment, because then you understand that you actually have to do an LCA to know the impact of those things. So it's like an LCA requires an LCA. That's a little bit interesting in the end of the day. It's like a dog chasing its own tail, in a way. So, but I have never used this planetary boundaries LCA. If that is something you have, it would be interesting to learn more about.
Yeah.
It's a method that one of our research group are working with it. It's mainly Priscilla, she's in one of them.
Ah, cool.
Cool.
That is amazing.
Anyway, here is where you can add everything, and you can also import here if you create it outside in Excel. And you can also export the method so that you have the correct format for CIMA Pro.
There's another thing in the chat.
Yeah, there's one more question in the chat. Okay.
Thank you, David.
Thank you for joining, David. Just one quick comment, Marcus and Anna, I will be sending a feedback form for all our participants. This is about the 2 workshops that you have attended, the social LCA and the environmental LCA, and your feedback is very important for us in the research school. According to that, we are going to plan for future workshops and improve the workshop quality. So please make sure to fill in the feedback. Thank you.
Yeah, thanks. Will do.
Definitely. And I don't know how much Annie has described to you before, but we are also developing digital education material. So that can also be useful for you in the future.
Yeah, that would be great.
Super. Okay.
Yeah, so right now we also have the course soon available in English. We will start the course in English in October. That is the plan. And in Swedish in September, next week.
Super. Thanks a lot, Louise, as well.
Yeah, thanks.
Bye now. Okay, so if that's about it, then maybe we should round up.
Any other comments from anyone? No?
Hope we gave you some food for thought.
A lot. Thank you very much. We really have learned so much from you through this 2 sessions, and thank you so much for your patience with us. We have been asking a lot.
Oh, that's just fun. It's great to have a dialogue.
Yeah. Yes, Stanley, please go ahead.
Oh, so when do we get like the license code?
I'm hoping to this evening or tomorrow.
Okay.
And I will send to you as well the material so that you have it at the same time.
Okay, Thank you.
slides and the exercise.
Good.
And if you have any questions, if they arise whenever you sit in this with the training codes later on, don't hesitate to email us or get in touch and we'll help you out.
Okay. Thank you.
Great.
You good?
Thank you so
Okay.
much. It's been a pleasure.
Thank you.
Thank you. Nice to meet you.
Have a nice
It's a
evening.
pleasure. Bye-bye.
Rest of the day.
Bye now.
Bye, everybody. Yeah.
Bye-bye.
Bye.
Bye-bye.